let's talk about wave. Okay, so when you go to the beach, you definitely see a lot of wave, but here we're talking about sound wave. Although we can't see sound, there is a wave that causes so that we can hear it. So, sound wave belong to a group called mechanical waves and more specifically longitudinal wave. This means that they need a material called a medium or a solid, liquid, or gases like to travel through. Unlike light wave that can move through empty spaces. Sound wave involve compressions where particles are pressed together and rarefactions where they spread out, just like what we do with longitudinal wave. Now, the speed of sound then the speed of sound change depending on the material it traveled through. So it moves fastest through a solid because the particle are more part closely together, like particle part closely together. So when we're talking through a sound, um, So, like when we're talking through a sound, we can definitely. So the sound will sound, make it easier for the energy to pass through. So it's faster to transfer the sound wave. Also, you can also hear it louder. Why? You know that solid are like part. You know that a solid have their particles inside the solid are partly close together, like they are really close together. So when we're talking through a solid, basically the wave just passed through the particles very easily, very quickly because they're all parked together. However, if we talk through a gases, no matter what gas it is, a gas, a gas is not parked to all part compression closely together. They're all over the place. They're just everywhere. You can move freely anywhere you want, not all parked together closely. So, a sound wave moves slowest through gases because instead of passing next to each other like solid, parked closely to each other, gases, due to spate out particle, they move very slowly. So they're just one place here and then they jump over to the next place. So it's more hard. So it's more slower to for sound wave to travel through gases. Same with liquid. So if solid become the fastest thing, solid make it easier for the energy to pass through, then liquid come next. So it's kind of in the middle, and then there's gases, which move slowest through gases due to the space out particles. So, and one more thing, sound can absorb by insulators, and also sound can be reflected. One more thing, we cannot see sound. However, if we do, then sound will look like this. It will go all up and down, and it can all, and like I said, it's a longitude wave, so you can see some part of it are compression together, and some of it are in compression and some of it are in rarefactions. So you could, if you want to see sound wave, you can put on like a computer program, say something, and you will see it. Compression, rarefactions, the sound wave, how it travel through, Okay, so let's practice. Sound wave travel faster in which medium? Like I said, because it is solid. Why? Because solid are parked closely together. The particles are parked closely together, so it made it easier for sound wave to travel through. Which type of wave is a sound wave? It is a longitudinal wave and mechanical wave. Here we have only longitudinal, so it is longitudinal. What happened during a rarefaction of a sound wave? Okay, what happened during a rarefaction? Well, the particle since it is not compressed together, so it definitely would not be compressions, but a rarefaction is where they spread out. So when the particle travel through rarefaction, they are just spreading out. Sound waves travel slowest in which medium? Well, it is gas, because due to spaced out particles, it made it harder for sound wave to travel quickly, like solid. Like they're not compressed to each other. Why do many recording studios have sound insulator lining their wall? Well, you can see many recording studios have this foam insulator lining their wall. And why? Well, first of all, solid are great at conducting sound because of their closely packed particle. So we can aiding the quick transfer of energy by adding more like solid around the room. And their gas, which spread out particles, so make it sound slower. So around us there is gas around, right? Oxygen, carbon hydroxide. So yeah, material like soft foams and fabrics that can soak up around us called sound insulators. So when sound reflects off a surface, it created like an echo for sound to travel. So it need a medium, a substance it can move through by making particles vibrate. So it make it easier to travel through like solid. It reflect right off. So yeah. My house actually have not a recording studio, but like a very small room, just about 4 meters square, and that's basically it's my room. But it's okay. I still have a lot of space to study. And since it is small, it make it easier for sound to travel. And then around this small room, mine, we have this foam thing, which is the sound insulators around it, so that it will make it easier for recording. It used to be a recording studio. It's not a recording studio, but it used to be a recording room. But now we don't use it anymore, but we still have those foam because, just in case some children bump into the wall, so they won't hurt. But it is a sound insulator since it used to be a recording room. Okay. Absorb sound and promote higher quality sound. Thank you for coming and have a great day.